Hello everyone. So today I've got the problem of height balanced binary search tree. Before diving into the solution, let's quickly discuss what is the question and what will be the output of this problem. So the first thing you need to understand is what is height balanced binary search tree. So the height balanced binary search tree is such kind of tree where each and every node in a binary search tree, the difference between its right node height and its left node height should not be greater than 1. What does that mean? That means, for example, if you consider the height of left height of node 1, then the height will be 1 2, right? And then so the right height will be 1 2. So this node is balanced because its difference is diff equal to left minus right, which is equal to 0 for this node. So let's consider this node. So what will be the its left height? Its left height is 1, right height is 1 2, and then the difference is its total right height is 2, left height is 1. That means 2 minus 1 equal to 1, which is equal to lesser equal to 1. That's why this is balanced binary search tree. So this one, is this the balanced node? Yes, because it's left is 0, right is 0. This is also the balance. This is also balanced. This one is balanced. We already calculated the difference of left height and right height of this node 1. And what about this? So this one has right height of 1 and left of 0. That means this node is also balanced. What about this? This 0, and then the left is 0. So that means this one is also balanced. Hence, the whole binary search tree is the height balanced binary search tree. All right. So how are we gonna approach this solution? So the first thing is we need to calculate. We have to go recursively into each and every nodes, and then we have to calculate the left height. We need to calculate the right node height, and then we need to see if the difference between left and right is less or equal to 1. If that is the case, then we return true, otherwise we return false. So that will be the approach. So how we will go recursively to determine like if the tree is balanced or not. So the piece of information like we have to return when we call the function recursively is we have to return two pieces of information. One is the height of the tree, and then another information is we need to know like if that node is balanced or not. So these are the two information we'll be tracking, and then if its balance is false, then we'll be returning, we'll be just bubbling up and then just return false. How do we call recursively into this binary search tree? So let's look into this. So first we calculate the left and right. So we go to the left recursively, we go left. So this one will get the height, so it doesn't have anything, so this will return 0, this will return 0. right? So this will, and then so this will have 0 because there is nothing in the left, there is nothing in the right side. So it will return whatever the height of its child nodes plus 1. 0 plus 1, it will return 1 to this node 2. And then this will go to the right side. So, and then this will come to the left. This will return 0 plus 1. It will return 1. This will go right. It will return 0 plus 1. Now this will receive 1 from both sides. It will get the maximum. So the maximum of 1 and 1 is definitely 1. And it will return 1, whatever the height of its child nodes, plus 1. That means from right node this is getting 2, and from the left node it is getting 1. So it will take 2, and then it will return plus 1, that is it will return 3. So the height of its left child is 3. Now it will calculate right, okay, and then it will go right. This will try to go left. There is nothing. It will return, and then it will try to go left. So there is 1. It will return 1 plus 1, that is 2. And then its left height is 3, right height is 2. So the difference between 3 and 2 is 1. That's why it is less or equal to 1. So the tree is balanced binary search tree. The another thing you need to consider is we are not just calculating the height of this one, and we are not determining just a single node. We have to determine each and every single node is balanced binary search tree. So what will happen is we'll just return every time we go to this node, we return the height of this node, that is 0, and then like if it is balanced or not. Yes, this is already balanced because it's left, there is nothing on the left, there is nothing on the right, so it is balanced. So is balanced equal to true, and then the height will be 1. And what will happen to this one? The left height is 1, right height is 1, so that's why it is balanced. It will return balanced, and then so on and so forth. Let's take another example where the tree is not balanced. Okay. Alright, so let's take another example where binary search tree is not balanced. So in this case, what will happen is we go to the left because we have to calculate the height. We go to the left, we go left, we go left. Now we'll start calculating the height. So what is the height of this? There is nothing, 0 0, so it will return 0 plus 1, and then it is balanced, it will return true. It will return 0 plus 1 1 and true, and then it will go to the right. There is nothing, 0, and then its left is 1, and then 1 minus 0 is 1, so it is balanced. It will return true. It will return true and 1. True and 1 plus 1. It already has got like 1 from its left side, so it will just add 1 and return 2 to this one. And this guy will have height 2 from its left side, and it tries to go to the right side, but there is nothing, and then it will return 0. And then, but the problem is it is getting the height from left side, that is 2, and then it is getting 0 from its right subtree. So the difference is greater than 1. That's why this binary search tree is not balanced. So what will happen is it will just return false. So if it is false, then it doesn't even go this side, it will just return false. Alright, so let's dive into the code walkthrough. So here we have got the binary tree class. It will have the left node, right node, and value. And the another one is we just wanna keep track of the height and is balanced boolean value. So it will be a lot easier just to create a class, and then we'll make our code a lot cleaner. So this algorithm will run in O of n time complexity, and then O of h space, where n is the number of nodes in the binary search tree, and then the h is the height of the binary search tree. Because we have to go through each and every node in the binary search tree, that's why it is taking O of n time complexity. So what we have to do is the tree info will just basically gives us tree info equal to, we'll just call tree info, will pass our tree, right? And then our get tree info will be a recursive function. So here we have to check the base case. If not tree, then we return new tree info, height will be 0, and then is balanced will be true. So if the tree is null, then it will be balanced, its left height and right height is both 0. That means we'll return just true. Otherwise, what we'll do is we calculate left height equal to left info, get tree info, tree dot left, and right info equal to get tree info, tree dot right. And then, so this is the tricky part. So what we have to do is we have to calculate each balanced. Const is balanced equal to, first we have to check if left info dot is balanced, and so this, the left tree has to be balanced, and right info dot is balanced, so both of these tree has to be balanced, right? And the final thing we'll check is, so we'll just get the difference, absolute difference between left info height and right info dot height, and then if the absolute difference is less or equal to 1, then that means the tree is balanced. So we return new tree info. So we have to calculate the height as well. So the height will be maximum of left dot height, right subtree height, and we add 1 and return it to its parent tree. So we'll pass height and is balanced. Now what we do is we just return if tree info is balanced or not. That's it. What we have done here is, so we just going through this function recursively, we get the left info. So the left tree will give you its height and if it is balanced or not. And then, so if it is balanced means like the previous tree has to be balanced, both left tree and right tree has to be balanced, and then only we calculate this the height and see if it is less or equal to 1. Before doing this, we need to make sure the left tree is balanced and right tree is balanced. If one of the tree is not balanced, then everything should be false. That is what this pieces of code is checking. And this algorithm will run into in OF and time and OF adds space. Thanks guys.